The question, two rigid boxes containing different ideal gases are placed on table. Box A contains 1 mole of nitrogen at temperature T0, while box B contains 1 mole of helium at temperature 7 by 3 T0. The boxes are then put into thermal contact with each other and heat flows between them until the gases reach a common final temperature. Okay, then the final temperature of gases TF in terms of T0. So according to the question, number of moles of N2 is, okay, if I say number of moles of N2 is given, that is 1. Got it? Okay. And the temperature, it is given T0, and number of moles of helium, that is given 1, and temperature of this box, helium box, is 7 by 3 T0. Clear? Now, if we bring them in contact, then what will happen? Temperature will flow from helium to nitrogen. So, we can say heat lost by helium equals to heat gain by nitrogen. So what is the heat lost? Just try to understand, because the volume is not changing. So what will happen? Because according to the first law of thermodynamics, we know dq equals to du plus pdv. That means volume is not changing. Okay, so at constant volume, right? At constant volume. So at constant volume, we know dq equals to cv dt with ncv dt. So we can write here dq, that means heat lost by helium, equals to, we can write here, because helium we have written by N2, so N2 CV2 V2 with delta T2. Okay, and for nitrogen we can write here N1 CV1 with delta or DT1. So what is the number of moles? We know number of moles is 1 here, and we know what is CV. The formula is CV is F by 2, okay, where F is the degrees of freedom, with R into dT2. What is T2 here? dT2, that means change in temperature at helium. So what was the initial temperature? Initial temperature is T, and what will be the final temperature? So they will come to a final temperature or same temperature, that will be TF according to the question. And what is N1 here? That is number of moles of nitrogen. This is 1, and CV1. And what is the number of degrees of freedom? That means F, because the formula is F1 by 2 into R with delta T1. So what will be delta T1? So that will be, okay, sorry, we have to write here the value of T here. So because T was 7 by 3 T naught, it was 7 by 3 into T naught, it was, okay. Okay, and what will be delta T1 here? So delta T1 will be the heat gained by nitrogen. So what is the heat gained by nitrogen? Clear? So we can write here heat gained by nitrogen, because it will come to the final temperature TF. So TF minus T naught, right? Okay, it was 7. It was 7. Just let me write it to once. It was 7. It was 7. Okay, it was 7. So 7 T naught. Just wait. I'll make it sure. It will be 7 by 3 into T naught. Okay, so we know the degrees of freedom for helium, because degrees of F2 is, for degrees of freedom for helium is 3, and for degrees of freedom for nitrogen is 5. So I will write down the value, that will be 3 by 2, R will be cancelled, so it will be 7 by 3 T naught minus TF will be equals to, and F1 is degrees of freedom is 3, so it will be 3 by 2. Okay, TF minus T naught, and what will be TF here? Tf is the final temperature minus T naught. Okay, got it? I did some mistake somewhere. It will be 5. F2 will be 3 and F1 will be 5. It will be 5 because degrees of freedom is 5 here. Okay, so this 2 and this 2 will be cancelled, right? So if I solve it, it will be 7 T naught minus 3 Tf will be equals to 5 Tf minus 5 T naught. That means if I solve it, Tf will be 3 by 2 with T naught. Okay, that will be the answer.